On this episode of This Week in Space, we'll be talking about Space 2024. This one's going to be a year for the history books. Stay with us.
This show is brought to you by Cisco Meraki. Without a cloud-managed network, businesses inevitably fall behind. Experience the ease and efficiency of Meraki's single platform to elevate the place where your employees and customers come together. Cisco Meraki maximizes uptime and minimizes loss to digitally transform your organization. Meraki's intuitive interface, increased connectivity, and multi-site management keep your organization operating seamlessly and securely wherever your team is. Let Cisco Meraki's 24/7 available support help your organization's remote, on-site, and hybrid teams always do their best work. Visit meraki.cisco.com/twit.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 94, recorded on January 19th, 2024. 2024 in space. Hello, everyone, and welcome to another episode of This Week in Space, the Space 2024 edition. I tried to make that sound like Space 1999, but I think I failed. I'm Rod Pyle, editor-in-chief of Astro Magazine, and it's my enduring pleasure to be joined, as always, by the illustrious Tarek Malik, editor-in-chief of Space.com. How are you?
Hello, Rod. Happy belated 2024. I know we talked a few weeks into it. So.
Yeah, well, you know, it's going to be 2024 for another 49 weeks, so you're in plenty of time.
All right,
so today,
made it.
We are going to gab a bit about this coming year in spaceflight.
Yeah.
You're right. I mean, we're just far enough into the year that we should be doing that. So hold on to your hats because it's going to be a rocky ride, as we've seen already. But before we go, a couple of housekeeping memos. First, our good friends at Twit need your help. We want to keep our show in the air and Twit available to all. So as I will beg you again at the end of the show, please consider joining Club Twit for just $7 a month because it'll help us all out and we'd appreciate it. And I'll give you the rest of the blurb at the end. Second, it's survey time. The annual Twit survey helps keep us informed of audience wants and thoughts and helps us to make your listening experience better. So despite my lame dad space jokes, please go to twit.tv/survey24. It'll only take you a few minutes. I took it the other day just so I could make sure that was true. And it really took me about 6 minutes. Your data stays private. And the last day to take it is January 31st. So you got
about a week and a half.
Yeah, about 10 days. And of course, there's a slot you can tell them where you heard the blurb to prompt to take it. So make sure you tell them that you heard it on This Week in Space because we might get a batch of cookies or something.
Ooh.
All right, it's time for my trademark bad dad space joke. I was a good dad, but the jokes are usually bad. Again, from our increasingly good pal, Tucker Drake, as he liberated from the Will Eisner book, 101 Space Jokes. I got to get this book.
I know, right?
I actually kind of like this one. Okay. Hey, Tarek.
Yes, Rod.
What goes ha, 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 thump, thump, thump?
I don't know. What does?
A three-headed Martian laughing his heads off. Oh, the audience liked that one. Okay.
I tell you.
Thank you, Tucker. And as always, we invite the rest of you, get with it, to send us your lame space joke as you will. And don't forget to do us a solid. Make sure to like, subscribe, and all that good podcast stuff because we love you. We want to know you love us. All right, let's get to some headlines.
Yes.
So, hey, a half a yay, one fist up for Japan, who made it to the moon, and that appears to be it.
Yeah, this is like literally hot off the presses. The press conference ended 15 minutes before we sat down to record this episode. But Japan is officially the 5th country ever to soft land on the moon. Their slim moon rover, if you've, and that's not a rover, it's a moon lander. And they call it a moon sniper because it was designed to test this like really super precise landing technology where it would like scan and then touch down within about 100 meters of a target zone. And it appears to have done that, you know, remarkably well. The only hiccup is that its solar arrays stopped working after it reached the surface. So it's not generating solar power. That being said, though, Japan is declaring it like a successful landing, at least. And I guess the hope is there that over the as time passes and the moon moves in its orbit, that the angles of the sunlight might strike its solar panels again. Maybe it's unclear if it like landed upside down or what, but they know that they soft landed, and that ejected these tiny little microprobes too, and they sent back signals.
Do that thing with your hands again. Tiny little microprobe.
That's my microprobe.
Okay.
Symbol.
You look like a crab for a minute, but that
yeah. And so a really big and exciting kind of day for JAXA, the Japanese Aerospace Exploration Agency. Of course, they would have liked a much longer time. It's working on battery power right now, but that battery supply is limited and it will run out.
I mean, it's like a matter of hours.
Yeah, it was like only as of the start of the press conference, they said a few more hours. And by that point, Slim had already been on the surface of the moon for about an hour or so. And I should point out that SLIM is, of course, in an acronym. It is short for Surface. What is it? I have it here. Surface Lander, a smart lander for investigating the moon is what it's short for. And, it took a long time to reach the moon, which is like the sad part. It took like 6 months because it launched in September. But at least it got there. It touched down. We expect to get some photos before the battery dies of its approach and landing. So there will be some stuff to study over time from this one.
Now, can I just take a moment here for us to all pat ourselves on the back, those of us listening in the United States, because your tax dollars over the decades have allowed NASA and JPL and Goddard and the other centers and universities involved in robotic exploration to take huge strides and have massive successes. And I think we've taken a lot of those for granted. Opportunity crawled across Mars for 14 years. We landed Surveyor lunar landers in the mid-1960s, and that was all a ramp up to Apollo, but they worked. And even the Rangers, after the first 6 failed, worked. Those were impactors. The earliest Mars lander, the Vikings, in 1976. So not to wax too philosophical about this, but it's astonishing what's been achieved by both the U.S. and the former Soviet Union, and of course now by China and India. But this is just a demonstration of how hard it is, and it's really valuable that different countries and now private companies are trying to learn how to do this for a lot less money, because we did chew up an appreciable number of tax dollars during the space race and beyond to do this. But I just, my hat's off to the people that have made it work both here and in the former Soviet Union back in those old days when, let's remember, transistors were a new thing in the 1960s and computers were really stupid and all hard-coded. And the ones that were actually able to record data did it on reel-to-reel tape in spacecraft like the Voyagers. So the fact that stuff worked as well and as long as it did, and the landings were successful as they were, as frequently as they were, is a really big deal. And again, we're just being reminded once again of how hard this all is.
Oh yeah, and Japan, JAXA is kind of declaring the landing itself a success. They said that the solar array problem is actually like a separate issue from the landing. At least at first blush, they're going to obviously look into it. But I should point out that this isn't Japan's first attempt to land on the moon. There was a small lander spacecraft on SLS for Artemis 1 when it flew. Yeah. The company iSpace from Japan tried to land a private moon lander on the moon, and that one did fail. And so this has been kind of in the wings, waiting to happen. And now that they've hit this milestone, they actually said that the head of JAXA that they will be building more landers for the moon to come. They're not going to stop just because of this issue, and just kind of like a watch this space, if you will, for the future. And of course, they're a partner with NASA too on the Artemis Accords and whatnot. So,
well, and that is an interesting point. And I don't want to stray too far from the headlines because we have other stuff to do today. But if you're designing something today, especially for private industry, if you're designing a lunar lander or a lunar orbiter or a Mars lander, Mars orbiter, or even a crewed spacecraft, you're not starting from zero like somebody did 60 years ago. You're looking at blueprints from a number of different countries, at least the ones you can get, of their spacecraft. You're looking at their technology. Then you're trying to compare that out to current technology, especially if you can use off-the-shelf stuff and what that's capable of doing. So you'd think it would be a lot easier, but even NASA's having trouble reconstituting lunar capable heat shields. So
well, and there's also a lot of partnership. I know we're going to talk about Astrobotic in a little bit, but another thing that happened this week was India landed on the moon. We talked about that with the Vikram lander, and NASA's lunar reconnaissance orbiter bounced their laser off of that lander, which has just been sitting there, kind of dormant. And that's because there's a NASA experiment on that Indian lander, and they're able to still pull the science out of it. This, many months later on. And that kind of partnership, I think, will also both spread the number of attempts that we're going to see coming forward, but also, you get some additional results out of a lot of these things that we weren't really looking for too.
And Vikram landed in December, correct?
Man, I'd have to go back. Has it been that long? It feels like it's been like a million years.
You said last week, but I think
no, the last few months, right? Because I think it landed in September because it was only there for the lunar day with the Pragyan lander.
Oh, you're right.
And then it went silent. We were waiting for it to wake up in September, and it didn't. So look
at us right on top of the moon here. All right, next up, Peregrine lander.
That's right. Speaking of the moon,
the Vulcan ran well, did its job. Flawless launch as near as we know, but and ejected Peregrine into a translunar trajectory, but that didn't work.
Yeah, well, last week we talked about the challenges that Astrobotic was having with the Peregrine lander. It had a fuel leak and whatnot, and it was they were trying to figure out if it would survive. As of the Thursday, January 18th. RIP, because Astrobotic has lost contact with Peregrine. It actually re-entered the Earth's atmosphere, so it kind of did the big loop, all the way out beyond. It went just a little bit past the orbit of the moon. The moon wasn't there, of course, and then it came all the way back. They were actually they're having a press conference as we were starting this as well, and talking about the Herculean efforts just to keep it going that long, because they were able to fire some thrusters and point themselves at the sun to generate the power that Japan's lander doesn't have, and so they're kind of counting it as kind of a mixed result. This was their first mission. They made it out to lunar orbit. They didn't get a chance to land, but they did get to go. They had a flight, like a good 10-day flight, to figure out what it's like to fly one of these missions. And it is a little bit of a disappointment. There's a lot of NASA payloads on this, 5 at least, 15 others for commercial payloads, including a lot of human ashes and remains for Celestis and Elysium Space. Those have all burned up in the Earth's atmosphere over the South Pacific. But this isn't their first, their last lander. In fact, in just a few weeks, Intuitive Machines, another private company, is going to launch, and you can bet that they were watching this mission really closely to see what they need to double check when that launches on a Falcon Heavy rocket in February. And SpaceX just put the call out for media to interested in covering that mission. So we're going to see how this goes back and forth, and see if Intuitive Machines will cross that finish line when I believe Astrobotic's next mission is the Griffin 1, which will have the Viper moon rover on it. So what they're going to learn from that, and hopefully we'll get off the ground.
And let's just remind ourselves, this is all part of NASA's CLPS program, which stands for Commercial Lunar Payload Services, which is their way of helping these industries move along, besides sharing data and engineering understandings and so forth. It's money, which
and
is
getting a ride to the moon at a bit of a cheaper price too, instead of
because the Vulcan. So the average Falcon 9 launch now is, I think, between $52 and $70 million roughly. Mm-hmm. And Vulcan's looking like it's going to be between
52 to 60 if it's a civilian flight. There's more
for Falcon
insurances
9.
And stuff. Yeah, for Falcon 9.
Yeah, Vulcan's going to be at least 130 million, right?
Yeah.
And have they addressed that in any of their press conferences about, hey, here's why our rocket costs so much more? I know that ULA's thing has always been, ours always launched perfectly, but SpaceX is kind of eating their heels on that one.
Well, that's a good question to ask if we can get them on the show.
I don't know if I'm brave enough to ask that one, but we'll see. All right. Last up, Axiom AX3 has launched.
That's right. A big week for private missions. A lot of private stuff going on in space, but SpaceX has launched their third private mission with a flight to the space station with a crew for Axiom Space AX3. They're calling this their all-European mission, even though it's commanded by NASA astronaut Michael Lopez Alegria. And for folks who don't know, to be an astronaut for NASA, you do have to be an American citizen. At least you did for when Mike LA joined. But he is representing Spain on this flight. And so you've got Spain, and then the pilot is Walter Villadai of the Italian Air Force. And if that name sounds familiar, it's because he launched on Virgin Galactic's Italian Air Force flight recently, and now he gets all the way to orbit. And European Space Agency reserve astronaut from Sweden, Marcus Want, and then Alper, and I do apologize in advance if I get this wrong. Alper Gezeravici from Turkey. Turkey's first astronaut has reached orbit on this flight. They launched Thursday, January 18th, so the day before we're recording this, and they'll arrive at the space station over the weekend for at least a 2-week flight up there, and then they'll come on back. But it just kind of goes to show you that there is this really clear pipeline now for these commercial flights, and these aren't like the tourists that you would expect that would be flying on all of these missions. You've got an ESA reserve astronaut here, which is an interesting arrangement in itself, that a European Space Agency astronaut can kind of do an end run around the normal process and get on one of these flights if you buy it privately. And so they're each doing actual missions for their respective countries, and it'll be interesting to see how that model plays out.
So it's a race to the finish to see whether or not we can have one of these headlines of he's the first person or she is the first person from country X to fly before I'm worm food. So I give myself...
I could be the first Mexican Pakistani astronaut, right? How about that? So, and Zadie, my daughter, could be the first Chinese Mexican Pakistani.
Do we have a scalpel to slice this sufficiently thin? Okay. We're about to go to break here, but before we do, I want to announce, because it's kind of a big deal for us, that the National Space Society and their International Space Development Conference coming up this May has secured William Shatner.
Oh, the Shat.
To join us, yes. He's going to be picking up an award and saying a few words. And of course, we have Jose Hernandez and a bunch of other luminaries coming, but getting the Shat was a big deal. So just had to pass that along.
So honored for this award. Right? That's my Captain Kirk impersonation.
Beach to walk on. Okay. We will be right back after this short break. Go nowhere. Let's talk about 2024 in space.
Let's do it.
Specifically. So first up, and boy, we got a lot of stories here. We'll get through as many as we can. I think the big one you and I have been talking about is the delay of Artemis, and we'll be having Pam Melroy on soon, Deputy Administrator of NASA, to talk about that. Was supposed to be here this week, but they got weathered out in Washington. So here we are, your consolation prize. But this is in a sense a good thing because we could talk about this a little in advance. So it's a little frustrating. I just want to say up front, I was online commenting somebody the other day. They were saying, "Oh, when's it going to fly, and why is it taking so long?" And if you were around during the space race years, which I was as a young lad, well, not that young, but young enough. You were used to delays, and there were a lot of them. There were the constant delays, largely with the lunar module, but with also the Apollo capsule after the Apollo 1 fire and so forth. This is just part of it. The difference is, there's a number of differences. The big difference experientially is that these delays we're seeing now are a lot longer, on the matter of years instead of months. But let's all bear in mind before we launch into this that we're still not sure what the exact margins are. At one point, I could have said Artemis is only going to cost 25% of what Apollo costs. But, as even adjusted, it's narrowing down a bit. And I think it's going to be closer to half or perhaps more. But it appears to be working slowly. So at the core of this long diatribe is the fact that NASA in the last 2 weeks has announced that Artemis 2 is delayed to at least December 2025, and Artemis 3, the first lunar landing, to 2026. I think we're all still a little queasy with that date, given what's going on with SpaceX's lunar lander version of the Starship. And I just want to add, before I turn it over to you, Doctor, that Representative Frank Lucas, a Republican from the state of Oklahoma, recently complained, we're not the only ones going to the moon.
Oh, no, he didn't.
Wink, wink, snarl, snarl. Of course, implicating China. But, we want to make sure these guys get back. So we have heat shield issues to worry about. We have battery problems. Apparently, there's some issues with the ventilation and temperature controls, although I'm not sure that would actually hold them back unless they're pretty severe. And of course, the biggies, the extravehicular activity moon suits that we haven't built since the 70s, and that great big lander that we need.
Yeah.
What's with the lander?
It's interesting that you mentioned the moon suits, because Axiom Space is actually building those suits right now. And they actually touched a little bit on that during their AX3 launch, saying that they're making progress, but they're not done yet. They're not finished. But yeah, it's weird that we're starting kind of our look ahead belatedly for the year for something that's not happening this year, because we were really looking forward to it. The original plan was for Artemis 2 to launch last year, maybe even a year or so earlier. And it just keeps, getting pushed to the right. And before this recent change, it was kind of in the November, December period for 2024. And so, all of those issues, the heat shield issues, the Eclipse stuff, the Artemis 1 did not have that life support system fully, tested out on it, because they were trying to just do the basic flight around the moon. And they have to get all of that stuff done. And that's something you do not want going wrong on your very first crewed flight on the new ship. And so they do have to kind of close all those boxes, and it is frustrating to see it, but it's I think a little bit easier to have the delay this far up front, right, than to have NASA be playing hunky dory for the entire year and then kind of pull that rug out later on. And of course they wouldn't be able to do that, because there's like milestones that you have to have in hand. And
excuse me, but just in terms of timeline, I think it's important to remember that hope I get these dates right, that we being NASA and the planners, were originally aiming for later launch dates for all this stuff. It was the Trump administration that said,
That's right.
I want it by this date.
2028,
and back by a couple of years.
2028 was kind of the target. 2026 to 2028 for Artemis flights to the moon. And of course it wasn't Artemis then. It was, just the moon plan. And when the Trump administration accelerated that plan, that's when they pushed it up to 2024. Then we saw the slip to 2025, and then now 2026 for the Artemis 3 mission. Now, what NASA did say, and we kind of touched on this in our last episode too, about Artemis plans for the moon, is that fourth mission, which is the one that would start kind of building out that architecture for the gateway bases and beyond, still is on track for 2028. So NASA is kind of targeting these annual flights in the fall, like late summer, fall, September 2025 for Artemis 2, September 2026 for Artemis 3, and then September 2028. Now that's a 2-year jump for Artemis 4. And then the missions would be annual, after that. And, budget wise, you were talking about that. These are supposed to cost, on comparative levels, to the space shuttle program, those flights, a few $1 billion a trip, if you will, going forward. And NASA has plans to fund, or at least to order enough SLS boosters, through Artemis 10 at this point right now is what they were looking at. In fact, the second booster core is under kind of final construction in Michoud as we speak. We've seen some of the photos of it already. So this does seem a lot more feasible. And of course, it's a new administration now, which is probably a little bit more amenable to delays of this sort. But hopefully this will allow the commercial partners to kind of catch up at this point, which is weird that we're saying that because they have to catch up with the work that NASA's working on so that they can have all of these things. But you don't want to have the way to get there and then nothing that you need to arrive. But the big tent for any of these landings that you're talking about is the human landing system, the SpaceX Starship, at least at this point, because they have to fly not one but at least 2 flights to support an Artemis 3 landing. One is an uncrewed moon landing with a Starship, and then of course the crewed landing with the Starship as well. Each of those Starship flights needs 10 flights to refuel the thing.
Well, a minimum of 10.
A minimum, yeah.
And let us point out, we both suffered through a press conference last week where they talked about this, and to his credit, Mr. Bill Nelson said, sorry, so let me back up. So somebody asked the SpaceX rep, I don't remember her name, sounded like a nice enough lady, as often happens with SpaceX, very young, maybe new to that job, I don't know. And so they asked, so, hey, who was it? Do you remember which journalist it was?
Was it Irene? It was.
I think it was Irene, right?
I think it was Irene. Yeah, Irene Klotz, Aviation Week, I believe.
Said, hey, thanks for taking my question. How many flights is it going to take to refuel this lunar lander to make it out to the moon and down and back? And there was on SpaceX's side a little bit of shuffling and muffling, and well, it's a few, and wherever. And finally, Bill Nelson, in a very uncharacteristic moment, said, "I believe the question was exactly how many flights is it going to take to refuel this thing?" Well, we think about 10, but they're not nailed that number. I've heard as much as 16.
Yeah, and it's gone. I mean, it's gone back and forth. I heard 18.
A 5 gallon pail at a time. I know it's big. I know it's new. I know this is different, but we've only had 2 test flights of this thing, both of which ended in less than optimum circumstances. And every time you see images of Boca Chica, there's all these starships lined up like soldiers waiting to take their turn at the charge. And I know that there are problems with Fish and Wildlife and FAA, and they got a lot of boxes to check. But man, they better hurry up.
Yeah, and it was interesting because that's a number that we've wanted to know for a while, and both NASA's own representative that was initially asked the question, and SpaceX did kind of hem and haw, and I think that Bill Nelson wanted to know as well. That's why we heard that.
Okay, I've got this on my scratch pad here. Well, and it's like asking about the life support system of Starship. Hey, how's that coming? Well, we have one in Crew Dragon.
Yeah.
Yeah, and what, are you going to put 10 of those in Starship? What are you going to do?
That's exactly what Elon Musk told me in 2019. That's exactly what he said. We've got it pegged out on Dragon, so I think it'll be fine. Now, maybe it will be, because I think that the interior of Starship is going to be very different than what the artist renderings had been, where we see like a ballerina floating, and whatnot. Yeah, I don't know if they're going to still cram 100 people in there.
Well, let's remember that a lot of those renderings came from third parties. SpaceX has delivered precious few things that would show us, other than in whimsical terms, how that thing would be configured at all. And it would make a lot of sense, I think, to have, how many people are heading down the lunar surface? 3 or 4?
Well, they'll have 2 people for the initial ones, right? And then the 4-person mission. It could be all 4 of them. We don't know. But the point is, if you take the Orion capsule and put it up against the very top of Starship, you don't need much pressurized volume for that. Yeah, exactly. And it depends on how much cargo you want to bring too. Now, they will have this giant elevator. In fact, the astronauts are testing that now. The towering elevator that's going to pop out the crew compartment and then lower the astronauts all the way down. Which,
excuse me, but if I had seen that in one of those awful Japanese sci-fi movies from my childhood, they had a couple of those movies that had a big rocket with a little elevator and a couple of 3-inch high figurines on it going and jerkily down the side. And I remember laughing, going, they'll never do that. Oops.
I know, yeah. Here we
By
are.
the way, John just wrote in. John Slanita wrote in. I'm sorry. We're supposed to use his call sign. How many refuelings to get to Mars?
Well, interesting question. 10 just to get to the moon. So What's the distance comparison?
Well, but you can only fill it, right?
Yeah.
I mean, if you've got one Starship headed to Mars, you can only fill it once. So probably about the same number. They just do their flight trajectory a little differently.
Yeah.
Well, gosh. Oh, and in a final little tagline, Mike Griffin recently came out and said, "Hey, Artemis is too complex, maybe even dangerous. I don't think it's going to work." And Mike
Griffin, former NASA administrator,
an engineer, which not all administrators are. So I appreciate that. He can be a little sticky at times, but I don't know. The part of me that's not rational says, dude, this isn't the time.
Yeah. Well, so Mike Griffin spoke, and actually you mentioned the Congress as well, during a hearing scheduled just after the delays announcements last week, scheduled for this week, about how to keep Artemis on track. That was the science subcommittee of the House's meeting. That's what it was called, how to keep Artemis on track. And Mike Griffin said, Artemis needs to be restarted, not kept on track, because of kind of where it is now. And so there is definitely kind of a lot of eyes. And you see this, the congressional, or not the congressional, the budget office, the watchdogs, they've been taking a real close eye on kind of all the different components, letting NASA know where the challenges are for SLS, why the limiting factor for the landing system isn't just SpaceX, but also, the suits and whatnot there, because you need to have all of that stuff in place before the astronauts can fly. And so, it's a bit of a pickle right now with all of these different programs, but at some point they're going to have to converge in the next couple of years to make a 2026 landing possible. I think it's doable. I think it's doable. It seems like there's just a lot of dots to dot and I's to dot and a lot of T's to cross. So.
But you said it's a pickle.
Yeah, well,
really?
I like pickles, right? So
okay, you weirdo. We will be back in just a moment after this quick break with our next exciting story. Stay with us. Do you mind if I go out of sequence on this next one? Because I just saw it before we started.
This is all up to you.
There's
which
a
ones
Blue
you want to
Origin rocket in the wild. I couldn't believe it. So after years of constipation, I mean, we've seen all this stuff go in the front end of the Blue Origin factories and foundries and offices, supplies and people and hardware and all this stuff. And then it's like as a little kid, you want to run around to the back of the circus tent and watch the elephants leave. And we waited and we waited and we waited. And okay, we saw the New Shepard. I give them that. But we kept waiting for the big rockets to come out. It's like, why the door still closed? It's been 24 years. It's been 24 years since this company started, and they've done a lot of cool things, but at a much slower pace than SpaceX, slower pace than SpaceX. But I'm wondering if maybe, and we still don't know this answer, I don't think, if maybe they're taking a little more of a ULA type approach to, we don't want to just toss them up and see if they explode. We want to fly properly the first time. So this is a long roundabout way of saying that a New Glenn booster core was seen headed towards launch pad, LC-36 last week. And it looks like a rocket, it smells like a rocket, it rolls like a rocket, but apparently the interstage and possibly the rear engine cluster are not flight hardware. So this could be, they do mating tests with the launch complex and so forth. So we just don't know.
And for John, that's line 36. There's like a nice link there for the folks that might watch the video for Twitter there, where you can see
36 or 39.
39. Pardon me. Oh my gosh, I can't even read today.
It's okay, Pops. Don't worry. I'll take care of it for you.
But this is actually, I have to apologize because we actually haven't written a story yet about these photos. And
I was stunned.
And I know we've been so distracted with everything happening at and around the moon this week that we haven't actually jumped on this. And I have to tell you, I was hoping that we would also see some photos from Launch Complex 36 of whatever is going on there. But for folks that are listening, on January 10th, so this is actually, it was last week.
9 days old.
I know,
Mr. Hourly news source. Come on.
But Blue Origin rolled out the first stage of New Glenn, this brand new rocket, to the launch complex 36, which is over at Cape Canaveral Space Force Station. That they've got what do you call it? Like a lease for? No, is that NASA? Is it at KSC or is it at NASA? 36.
It's on the. I think 36 is on the Canaveral side.
It's on the Canaveral side. That's what I thought. And they moved it there for what I think are most likely like fit checks, right? To show that they can make the drive from. If you've never been to the Kennedy Space Center Visitors Complex, as you drive there from Merritt Island, you pass by this sprawling Blue Origin complex, this huge white buildings with a big Blue Origin logo on them. There's also like a mini VAB that they have there for what I think are vertical assembly and tests that you can see with big doors and everything. It's really cool. But they have to get the boosters from there to the Space Force Station and their launch site. And what I suspect is that this was like a rollover to show that, all the processes that they know how to load the booster on the thing and get it to what I assume is a hangar over there. I haven't been at the site since they made the initial announcement, when Jeff Bezos was there with his shovel to say, yeah, we're going to build it here. So I haven't seen what it looks like now. And we didn't hear anything after, which is so Blue Origin, right?
The North Korean space companies.
We didn't hear that it got to the pad okay, or that it got to their complex okay, and what are they doing there? And it's a commercial company. They don't have to tell us anything. And in fact, I've told you the story before, but we've had Leonard David on the show several times. And when I first became the spaceflight reporter, I called Blue Origin to introduce myself to them and to ask them the status of their programs. And this is like early 2000s, right? And they told me to give Leonard David a call. He seems to know what we're up to. I always thought that was really funny.
So the question is, were they being obfuscatory or did they really not know?
I think at that time they were just, they were working very quietly to make sure that the stuff worked. Because when they did release the initial Hopper tests, it was fantastic and it was stunning. And I suspect that a lot of...
You're talking about SpaceX or Blue Origin?
No, this is Blue Origin. They have like a Hopper that came out before New Shepard, like a prototype.
Okay. And
they just kind of casually slipped out the announcement that they had done the test weeks and months earlier, and how amazing it was. But it's interesting because like we talked about this with the Vulcan launch recently. That was great success for United Launch Alliance. Amazing, right? But not a lot of people were talking about what a success it was for Blue Origin because they're the ones that built those first stage BE-4 engines. And they're going to use a cluster of those engines on this rocket. So now we know that the engines work. And now we know that they've got the infrastructure that they're rolling stuff out, to the launch pad. So, they're supposed to be launching their first New Glenn rocket sometime this year in 2024, which will have, I think on our list is later on is a mission to the Mars that's built by Rocket Lab and flying on New Glenn, and so a lot of that on this, and then they have all sorts of plans for their Kuiper satellite system, Amazon's Kuiper satellite system to fly on these rockets themselves too. So this is a really big rocket. The diameter is bigger than anything out there right now. And
that's what's so interesting. People are of course jumping into the numbers game. So, New Glenn is 322 feet. Falcon Heavy is 230 feet, but of course, it's a triple cluster instead of a single tube. New Glenn's 23 feet in diameter. Falcon Heavy, at least the cores, is 12 feet. Is that right?
Yeah. About that.
But of course,
the core is a little bit bigger than the Falcon 9.
Yeah, and the fairing could be larger than the core, so that's a little flexible. But here's the big one, and these are the most recent numbers I saw. They're probably out of date already. It's been 15 minutes. Payload for New Glenn to low Earth orbit is 100,000 pounds, roughly. And Falcon Heavy is 141,000 pounds. So a lot of people are asking, well, why the disparity? And is this an expendable or in recovery mode? And those things I could not find. Do you happen to know?
I don't, but I know that the whole goal for New Glenn is for it to be fully fully reusable, not like Falcon Heavy itself. They do have an ocean barge kind of landing profile, similar to what we've seen SpaceX do with their Falcon 9 and their Falcon Heavies. But one of the things that they do tout is just the sheer size of their payload fairing. It is the biggest that out there. Well, not including, I guess, Starship for whatever they're going to do to carry payloads on that thing. And that will be very, very interesting to see how it changes what types of things you can launch in one big go on that one. And so it'll be interesting to see how that all shakes out. And then they have been testing those fairing separations as well at the Kennedy, at the Cape Canaveral staging grounds and whatnot. So, but I think it's going to be a really big year for Blue Origin. Well, they recently returned to flight with the New Shepard, so they've got that revenue pipeline started, at least for uncrewed flights. And so we'll see how that goes on the tourism side of things. And then meanwhile, they've got BE-4s to deliver for the next Vulcan flights, which might even happen later this year. We'll have to wait and see. And then of course their own New Glenn flights, and hopefully we'll be able to get down there together, Rod, to go see that one get off the ground.
All I need is for space.com to pay for it, and I am still there. So you bring up a good point, which we've hardly ever talked about on the show, which is the diameter of the payload fairing for these rockets, of course, determines what can fly. And why is that a big deal? Well, if you're doing something that has to deploy in a substantial way on orbit, like something like the Webb, the smaller that fairing, the harder it is to jam that spacecraft in there. So with a bigger diameter fairing, you've got a lot less engineering to do to get these things to deploy and be able to work properly. So this would apply to space telescopes, private space station elements. If we ever get space solar power going as a serious concern, we're going to have a guest on a couple of weeks talking about that. That's going to be huge because, of course, it's multi deployable structures. All kinds of origami you have to do to accomplish that. So bigger fairings will be a big deal, which is, of course, why we've all been lusting after Starship, but we still don't know how Starship's going to deploy payloads. So
and if folks are wondering what we're talking about in terms of like the bigger payloads, the New Glenn fairing is a 7-meter diameter fairing, and Blue Origin touts it as twice the volume of like the more typical 5-meter diameter payloads, which are a little bit more common. Okay,
stop talking like a snotty European.
No, I'm just I go by meters. You know why I say meters? Because I can't do the math in my head, Rod. So.
Okay, just treat it like yards. You'll be close enough.
That's right.
Let's take a break here, and we'll be right back with a couple more stories. And once again, we're not going to get through the list, but we'll be right back with you. Yeah. Someday, I declare we're going to make it through our whole rundown, but not this week.
I think we just have our eyes are bigger than our stomachs when we want to talk about space. Is what
I don't know. My eyes are very big, and my tummy certainly is. Is big enough to fit in the New Glenn payload fairing. So let's just take a quick look. You put a bunch of stuff in here too, but I just want to talk briefly about JPL and NASA's robotic plans for 2024. We got Europa Clipper launch in October, which is a big, long ramp up flagship mission. That's going to be very exciting.
I actually got a chance to see Europa Clipper in October when I saw you, Rod.
Yeah.
I saw it under construction. In fact, everyone else can too. If you go to the Europa Clipper NASA website, europa.nasa.gov, you can see the Clipper cam.
Yeah, but you saw it through a pane of glass.
That's right. This is really exciting because, Europa was the first thing I wrote about when I started as an intern at space.com too. And the story back then was, does it really have an ocean underneath? And this is like the mission to find out what that ocean is like and how deep does it go? How big is it? How warm is it? What's going on with the
but all from orbit. Let's just be clear.
From orbit.
It's not like we're landing and drilling or anything. It's all from orbit. So there's going to be a lot of intuition going on.
We're going to Europa, Ross, this year, and this icy moon of Jupiter. One of the best chances to find the conditions, at least, to support alien life, even if it's just microbial. I don't know if the real aliens are going to come after us, because the film 2010 told us.
I was just going to say, stay away.
All the worlds were ours except Europa. Attempt no landing there. And so
Arthur C. Clarke is no longer with us to ask, wait, is it okay, or did you really mean that? Because we don't know.
Although, wasn't it Iapetus at Saturn in the original book?
I didn't read the original book.
So,
it was certainly Europa in the movie, but we're not landing. It said, do not attempt a landing.
That's right.
It did not say, as I recall, you can't orbit. But it's interesting when you start looking at the instrumentation. So I haven't actually kept up with the story. It's a couple of years old. Mm-hmm. But there was a story I wrote for the JPL technical annual I was doing about how you sample stuff coming out of Europa from those plumes from orbit. And apparently
these water plumes that we've seen through like Hubble telescopes and stuff, other things. Yes.
Yeah. And the second they exit the crust of the planet, they turn into ice crystals, right? Mm-hmm. So you've got to scoop these things up if you're going to evaluate them. Well, you're going really fast because you're orbiting and you're dropping a scoop, and these are ice particles. So they're going to do various things when they hit the metal or the composite of the scoop. Yeah. And holy Moses, you start reading what these guys have to test and think about. Well, at these speeds, an ice crystal will instantly vaporize into water. So we have to make sure that and here's what the molecules do. And we have to make sure we do this to capture them. And then this part of it is the integrity is damaged as far as testing goes. And it's like, wait a minute. I thought you were just going to stick out a vacuum cleaner hose and grab some ice and go, hey, look, here's what's in it. But oh no, like everything else in spaceflight, it is unbelievably complicated. And that's just one little aspect of the mission. They've got to worry about spectroscopy. They've got to worry about magnetometers. You have to keep them far enough away from the spacecraft. They can do their thing without interference. You have to worry about propulsion and attitude control and whatever kind of AI implementation they're going to have on board, if any, and data. And I don't know how they do it.
And you got to get there too. I mean, this is launching on a SpaceX Falcon Heavy rocket. And I think that was a change, because initially they might have wanted to launch.
It's going to go on SLS, right?
On SLS. Yeah. So that's added, a lot of extra complexity. They got to make sure that the Heavy will be able to do what it can. Obviously, it can, or they wouldn't be doing it. And they've got about 50 flybys of Europa planned for this mission. Really close ones. I mean, like 16 miles away. I mean, that's about the distance between my house and New York right now. So maybe a little bit more. They're going to get that close to the moon to fly over its surface and from different areas to scan almost the entire thing. And I think it's going to be just amazing. And of course, they'll do some other stuff, because they're flying around the radiation environment for Jupiter. They can measure all of that as well over time. And it's not small. It's not small. It's going to be 16 feet high, with the largest with these huge solar arrays. NASA says that it's the largest spacecraft they've ever developed for a planetary mission, and so that makes it like a record breaker across the board. This comes after they flew Juno to Jupiter, which has the biggest solar arrays they ever built for planetary missions.
Because it's dark there.
Yeah, it's the size of a tractor trailer.
It's dark out there. But now, were you surprised? Every time I see these things from the high bay, which isn't very often, the last one was, I think, the Webb, but it's always kind of astonishing how large they are.
Oh, yeah.
You see pictures of them, and you see people standing next to them, and you go, oh, that's kind of big. But then you go and you see yourself, and of course, JPL stages these things cleverly. So they always have, I think they go out and get the short people to put in the right spot and walk around if you're there with the media. But it looks like a great, big, huge thing. And yeah, well, good luck to them. This is a mission we've been waiting for a long time. It could be really exciting. And,
well, it will be. And we're going to be spoiled for choice when it comes to it, because Juno will still be at Jupiter, hopefully, doing its thing and capturing amazing images. You've got Juice. ESA's Juice is on the way, too. So when they all converge and they're all hopefully working at the same time, that would be really, really cool to have three spacecraft doing three different missions in the Jupiter system.
When you say ESA's Juice is on the way, If somebody was just now tuning in and didn't know the context, that sounds kind of weird.
The European
Can you
Space
explain that,
Agency's
please?
Jupiter Icy Moons Explorer.
Thank you.
Sorry. Another spacecraft, which also launched in April, I think, of last year, in 2023.
So let's talk about ESA because we've got limited time and a lot left to look at. But so JUICE is heading out. That's a European Space Agency mission.
Yes.
HERA, which was, if I remember correctly, originally supposed to go out coincident with the DART mission.
Yes.
The asteroid redirect. Asteroid redirect brings back uncomfortable thoughts.
Double asteroid redirect.
Double asteroid redirect mission.
Rendezvous
Basically
test.
nudging a moonlet of Didymos. HERA was supposed to go along as an observer or something was, and that didn't happen. But now it's heading out much later. And in a way, there's an advantage because we can look at the alteration of Didymos. What's the proper name for it? It's not Didymoon. That's what we were calling it.
Dimorphos?
Dimorphos. Thank you.
Dimorphos?
The moonlet around Didymos that was actually impacted by the DART mission. We can look at the changes over some range of time and really see by doing the math backwards how much effect that thing had. And as it turns out, from my basic physics class and very basic stuff about spaceflight in college, when you looked at this thing the size of a golf cart running into a 500 foot diameter rock, wait, was that about right? Or was it smaller than that?
I think it was kind of, man. This is just September.
I know we have to look up the numbers. Anyway, running into this much bigger rock, I thought, it ain't gonna do nothing. My layman's brain. But as it turns out, it had like about double or triple the effect that they expected. So it's going to be really fascinating when HERA gets there and says, hey, it's gone. We don't know where it went. You knocked it out of orbit or whatever. So that'll be exciting. But that's not all that ESA's got coming. There's more. No,
yeah. You pointed out that the ESA teamed up with China to launch their Einstein probe, which is this X-ray telescope to look at black holes and whatnot. They call it a lobster eye space telescope because it has all these different kind of cameras. It looks really, really freaky and sci-fi. But that actually did launch this month. Ariane 6.
Which of them actually built the hardware?
Oh man,
telescope itself.
I think that China built primarily the telescope, and then ESA built a lot of like the guts and stuff inside it, if I understand correctly. And I don't follow them that closely because I'm mostly like
keep listening, ladies and gentlemen. We're the experts.
We are. Well, if you want to know about rockets, the Ariane 6 is supposed to resume its testing after they had a lot of challenges on the development side for that, and so hopefully we'll be able to see that one get off the ground a little bit quicker than we've seen some of the other stuff. So.
Can I be obnoxious for a moment? Not that
you never have to ask, Rod. So.
I never do, and not that it's unusual, but it astonishes me. So, decades ago, Ariane from Europe was kind of this upstart. Wait a minute, Europe builds rockets. What's going on here? A primarily French effort, and I think that the traditional old school aerospace contractors of the U.S. were nervous about it and possibly still are. But at this point, having watched the ascendancy of SpaceX over the last 2 decades, and particularly the last 10 years, basically owning global launch to a large extent, you look at Ariane and part of my brain, pardon me for this, ESA, but part of my brain goes, why are you bothering? I know you have to, right? I mean, it's national pride. It's keeping industry going and all that. But it's almost like you want to go to all these other rocket companies, which I would definitely never do with ULA, and say, why would you do this? It's like, just let Chevrolet make all the cars in the world. Not the way to do it. You want competition. You want to have a second supplier, as we do in the U.S., in case something happens to the first one, and especially when it's owned by Elon Musk.
Well, and it's a painful lesson. I mean, we only have to look to our own backyard to know what not having your own dependable access to space, are. We had,
got a rocket in your backyard? I don't.
No, well, I mean, like the
national backyard.
The national backyard, right? Where between 2011 and 2000 and 12, 2020, we had no ability to launch our own astronauts because we didn't have a vehicle that could do it. Now that's one example, right? When Axiom Space, the French aerospace giant that does build these rockets for the European Space Agency, is retiring their Ariane 5 rocket, and Ariane 6 is the next heavy lift that's going to do it. Right now, it's 4 years behind schedule. 4 years compared to SLS is like a drop in the bucket, right?
You're harsh.
But it's not going to launch people, at least at this point in time, and it does have a fairly firm date. It's targeted right now for June 15th of 2024. If they make that date or not, it remains to be seen. But there's a lot riding on it because this is kind of the first of their new vanguard. They're also developing reusable rockets a little bit belatedly, like everyone else who's not SpaceX. They're looking at ways to do vertical landings and all of that stuff. And but first they have to make sure that they have that continuity going forward. And this would be it. So, it wouldn't surprise me if they got there by the end of the year. And June is still a long way away, and they announced that in November, which sounds like a very conservative number. So we'll have to wait and see if they get there.
So we have about 14 items left.
Yeah,
I'm going to let you wait. I'm going to let you pick the last story because you're Mr. International. So that'll be on you. But I just want to say, you mentioned, look in our own backyard. I almost had a rocket in my own backyard when I still had a house before I let go of it. I was teaching an executive education program at the Johnson Space Center in 2009, 2010, and we were driving out the west exit of JSC through the fields there where all the Longhorn cattle are, out adjacent to the Saturn V building and all that. And I'm looking over the left, and there's this Titan rocket sitting there with a boilerplate Gemini capsule on top. I said, "Excuse me, can you stop for a second?" And we had the chief knowledge retention officer there, lovely lady named Jeannie Angle, and I said, "What is that?" She said, "Oh, I think it's an old mating test item." So it looked like a Titan, but it didn't have tankage inside. It was empty with some cruciform braces in it and stuff. And it was a little oblong from having sat there over time, but it was a Titan. And I said, "Well, who owns the property?" She said, "Well, it's JSC, but it's leased out for cattle grazing and all that." Bottom line is that thing was up for grabs. And I have to tell you, there was a moment there after I got home back to Pasadena for that particular trip and thought, I wonder if the city has a limit on how tall I could put something in my backyard. Because how cool would it be to have a Gemini Titan sitting in your backyard when your guests come over and say, "Hey, I got something to show you." But I got a model rocket in the backyard. They're going to expect something 3 feet tall. And whoa!
I'll tell you, I'd go see it. I'd charge tickets, man. I'd pay for tickets.
Absolutely. All right. So sorry, last story's on you.
All right. There's a lot that there's a lot more to look forward to in the year. You've got Polaris Dawn for SpaceX with the first private spacewalk. You've got the first Dream Chaser. I would say though that for me the most exciting story that we've been following will be the final development possibly of India's first crew capsule. The Indian Space Research Organization, has said, like many other countries, that they want to launch their own astronauts into space. But what we've seen in recent years is a trajectory of testing and vehicle hardware development that says that they're really serious about doing it themselves. They have this GSLV-3 Mark III launch vehicle that they're going to adapt for human spaceflight, and they've had some challenges with it, and they've returned it to flight, and it's doing quite well. And at the same time, last year in 2023, they did test a prototype capsule for I hope I pronounced this right, the Gagaanyan human spaceflight program.
I think it's Gagaanyan, but yeah.
Gagaanyan, is that? Yeah.
I think so.
And they've been developing their own spacesuits, and they actually announced the spacesuits quite early, a few years ago.
Can they make some for us?
I know, right? And so this year they're expecting to do at least 3 more abort missions because they've already launched one for this capsule to prove it out with the goal of having it ready for flight and operations, if at least an uncrewed test in 2025. That would be a test into space, and I just think that that's really interesting to follow because while it is informed by a lot of the other programs, it is different. China launches on Shenzhou spacecraft that are very much informed and developed on Soyuz spacecraft. They're modeled after that. And this new one is, it looks squat and wide. It's made for a completely different rocket. It does seem very much homegrown, and it'll be very interesting to see how that develops over time. And I believe that, India and has had some cooperation with China and with Russia in the past, but also a lot of cooperation, like we were just talking about, with NASA as well. And seeing how that partnership evolves will be very interesting in terms of like not just orbital cooperation, but also possibly lunar cooperation in the future. Very excited about that.
Well, me too. And once again, we've reached the end of our hour, and I hate to keep saying this because I never stop, but I think we need a part 2. Maybe
there's so much more to come.
Yeah.
Starliner. We didn't even talk about Starliner. April 2024, maybe.
What's a Starliner? I've never seen one before. Oh, the mythical Starliner.
Yeah.
It's like
astronaut Sonny Williams has been waiting years for that flight. So let's hope that it gets off the ground.
The Loch Ness spacecraft. Okay, fair enough. It'll fly someday, but maybe when we have Isaac come with us, we could talk about more of this stuff, because I'm sure he'll have things to say. But of course, they'll all be 300 years in the future, because that's where his brain lives. Well, we've done it again. You spent another hour with us this week talking about space for 2024. What we know is happening, what we hope is happening, and what we're pretty sure isn't happening, which is anything to do with NASA's human landings on the moon. But there we go. If you have comments, please feel free to send them along. We're always here to listen and respond nicely most of the time at twit.tv. That's TWIS at twit.tv. Tarek, where can we keep an eye on your incessant video gaming?
Well, you can see me at space.com as always. And on the Twitter at Tarek J. Malik. And I am trying desperately in 2024 to finish Star Trek Resurgence at Spacetron Plays on YouTube. And
is that a game?
It's a game, yeah. And I died for the first time, and it was horrifying this weekend. But you can find the latest there. And one thing we didn't talk about was skywatching April 8th, 2024. Big total solar eclipse. We were just talking about Spaceflight, but I would be remiss if I didn't say I'm planning this weekend to do all the travel for that. You should be too if you want to go see it.
Well, but please don't go to Texas, because that's where we're going to be, and we don't want the competition. And I am told that hotel rooms in the area are going for as much as $800 a night.
Oh my gosh.
That can be for a budget inn or a Motel 6, not anything fancy. So if you haven't made your plans, you're probably going to be way off the path of totality, and then you're going to be part of the traffic jam heading in. I, of course, have made my plans.
Well, you're so far ahead of me.
I don't have airline tickets yet. I just have a place to stay. But yeah, it's going to be a zoo. But having years past, I would say, oh, I got to go see an eclipse someday. And then when 2017 came, I looked at my watch and realized that my death timer was counting down. And I said, hey, this is not good. So I went to see it. And once you've seen one, you're addicted. You want to go back and see them all. It's like nicotine, you say suddenly, ooh, I got to do this. So where are you headed?
I'm probably going to be somewhere in New York State, somewhere I can drive to be honest. So,
okay. I thought you were going to go to Texas.
No. I'm likely going to be spending.
You don't care about actually seeing the sun, right?
Well, fingers crossed. We're going to have a nice day. We'll have to
look at the clouds getting dark. How exciting that is! All right, and don't forget to check out space.com. The website's in the name of the National Space Society, and NSS.org. Both are good places to satisfy your spaceflight cravings. And I forgot to say that you can find me at pilebooks.com and at astromagazine.com, and increasingly in other places. New episodes published every Friday, so look for us on your favorite podcatcher. Make sure to subscribe so you don't miss any. That makes it much easier than searching us out. Tell your friends and give us reviews. We'll take anything we can get. The more thumbs you give us, the better. That sounded kind of off, but you get what I'm saying. And you can head to our website at twit.tv/TWIS. Don't forget, you can get all the great programming on the Twit network and free on Club Twit, as well as some special stuff that you can only find there, which is very cool. Extras where I give Tarek a particularly hard time off air because I can. For just $7 per month, you've heard Leo talk about the challenges facing the podcasting industry. This is your time to step up and be counted. So join us in Club Twit. You can also follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook, and twit.tv on Instagram. Thanks, everybody. See you guys next week. Take care.
See ya.